Okay, hello everyone. Today we're going to go over section 9.3, which is about linear relationships. So, one of the things that we want to clarify for going over linear relationships is the difference between a formula and an equation. So, a formula is a mathematical statement that represents the relationship between two or more quantities. So, I know that's a very technical definition, but what that essentially means is, let's say, for example, you are calculating the area of a rectangle. The formula for that would be A equals area equals to length times width. So in this case, it is a relationship between the quantities area, length, and width. And that's a good example because there are actually three quantities involved, right? So a formula can involve just two quantities or more quantities than that. So in this case, we have three. Another example would be something like E equals mc squared. So that's a very famous formula, of course. And we'll talk about the parts in that formula in just a second. So this is again about the relationship of two or more quantities. Usually when we are looking at something like the area formula, um, we have what's called variables. So A, L, and W are all variables, and so are E and M. However, C in the formula E equals mc squared, that is not a variable. It is actually a constant. So let's look at what that constant means. Okay, so here we have E. E stands for energy. M is mass. And C squared specifically is the speed of light in a vacuum squared. So that is a mathematical constant or scientific constant because it is not going to change, right? Like if you write it out as a number, that number is unchanging, squared. Okay, so it is important then for you to distinguish in formulas such as these which ones are constants and which quantities are variables. So in this case, both energy and mass are the variables. Okay. So for the area of a rectangle formula, length, width, and also the area, those are all going to be variables. Okay. Because of course you can have um, rectangles of different sizes. So you can change the length or to change the width, and um, it would change the area. Width. So these are all variables. So let's look at an example where we use a formula in that is linear in nature. So it says here Paula rents a lawnmower for $8 per hour. A formula representing this relationship is C is equal to 8 times T, where C is the rental cost in dollars and T is the time in hours. So we're going to make a table of values for the first 5 hours. So here we're going to have T, which is of course time. We're going to put it in the left column because that is the independent variable. And then the dependent variable is cost, and we'll put it in the right hand side. So we can say that T is the independent variable and C is the dependent variable because of course the cost, depends on how long you rent the lawnmower for. So from there, let's see, we have first 5 hours of the rental period. Let's see, 1, 2, 3, 4, and 5 hours. So 1 hour will be $8. 2 times 8 is 16, and then 24, 32, and 40. So we're going to go ahead and graph this as well. Remember, we have the four different ways of representing a linear relation. So we're going to go over a few of those right now. Okay, so recall that positive x and y values will be in this quadrant that we're working with right here. And then negative negative x value, positive y value will be here in this quadrant to the left. If both x and y are negative, will be on the bottom left quadrant, and the bottom right quadrant will be if x is positive but y is negative. So in this case, our table of values only shows positive values. So it will be looking at just this quadrant on the top right. Okay, so we have the two variables t, which is time, and c for cost. This is in terms of hours. This, of course, is in terms of dollars. So we're going to have 0 at the origin, 1, 2, 3, 4, and 5 hours. And then on the y-axis, we can simply put in 8, and then 16, 24, 32, and 40. Okay, so that makes it very easy for us to plot. We have 1, 8, 2, 16, 3, 24, 4, 32, and 5 and 40, of course. So this is a linear relation. As you can see, it forms a straight line when we graph it. So the question is it reasonable to have points between those on the graph? Now, it depends on whether the cost is prorated. So if something is prorated, means if you rent it for part of an hour, you pay for that part of the hour. So we're going to assume that this time we're not prorating this. Then the answer here would be no. Lawnmower is rented by the hour only. So if you rent it for 2 hours and 30 minutes, you probably will get still charged for 3 hours. Now, if it was prorated, then you can have points in between. So let's say, for example, if you rent the lawnmower for 2.5 hours, then you'll pay $8, $8, and then another 4 hours. $4 for the last half hour. So the question doesn't explicitly say whether it is could be prorated, so we don't know for sure. Okay, so next part, we're going to go ahead and calculate the cost to rent for 12 hours using just the formula that we're given. So of course, C is equal to 8 times T. So we can substitute in this time around 12 for the time, and 8 times 12 is $96. And again, this is for 12 hours. Okay, next part, an equation It's a little bit different. I'm going to give you the definition that we have here. An equation is a mathematical statement with two expressions with the same value. Oh, sorry. So what does that mean? Well, we can have something as simple as, let's say, y equals 7. So the variable y is equal to 7. So it will just be equal to 7. We can also have something a little bit more complex. We can have x plus 2 equals 3. So of course you can find out what x is equal to. X is equal to 1 because 1 plus 2 is 3. And then you can have equation involving more than one variable. So let's say y minus 7 is equal to x plus 4. So depending on what y is, x will change accordingly. So let's say if if I don't know, if x is equal to 5, then we have y minus 7 is equal to 5 plus 4. So y minus 7 is equal to 9. So what number minus 7 is equal to 9? Well, that would be 16. So that would then depends on the values of x and y depend on each other. So you can change the value of x and change the value of y. But in this case, that would be a linear relation. Okay, so let's look at another example. We're going to use the equation y equals 2x plus 3. First, we're going to make a table of values with x and y. X, and I guess y. Oh, sorry, that's very hard to read. Y. And it says to use these specific values of x, so negative 5, negative 3, negative 1, 1, 3, and 5. And you should notice pretty much immediately that the common difference here is 2. We are always adding 2 going from one x value to the next. So the common difference is 2. Now for the y values, let's give a quick look. I'm going to substitute in the y values into the equation here. 2, and then if x was negative 5 plus 3, 2 times negative 5 is negative 10. Negative 10 plus 3 is negative 7. So the corresponding y value is negative 7. Just going to do a couple more to see if there's a pattern. Now 2 times negative 3, the next x value there, plus 3. So that will give us negative 6 plus 3. So that's, of course, negative 3. So here the corresponding y value is negative 3. One more. 2 times negative 1 plus 3. That will give us negative 2 plus 3, which of course is 1. So the corresponding y value for x is equal to negative 1 is 1. And you might notice now that there's a common difference pattern emerging, and that is there's a common difference of 4. So moving from left to right, as these x values increase by 2, the y values will increase by 4. And that's twice as much, which makes sense because we have a 2 in front of our x there. So then increase by 4, we 5, 9, and 13. Okay, so next up we're going to go ahead and plot these points. It's going to make a easy to see x and y axis first. All right, so plotting the points from left to right, we have -5, so 1, 2, 3, 4, 5, and then down 7 spaces, so that would be 1, oh, sorry, how do I show this? 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7. So this is where our first point will go. -5, -7. And then from there, we can move to the right 2 spaces and then move up 4 spaces because those are the common difference of x and y respectively. So then we have -3, -3. We will have -1, 1. You might notice already that we won't be able to fit every point on the graph, but that's okay. We have 1, 5. And finally, we have 3, 9, which is up here. So what you will notice right away is that these points, they form a straight line. Let's go draw that in. Which is good because we arrive at these points using a linear equation. Okay, so the next little part is just 3 different ways of asking the same thing. It gets trickier and trickier. So it says to use the equation to calculate the y-coordinate when x is equal to 9. So we can simply go back to the equation, which is, of course, y equals 2x plus 3. And then we'll substitute the x value of 9, and then we add 3. So 2 times 9 is 18, and then 18 plus 3 is 21. Follow that up with next example. It says here for the point -12 and then comma y, what is the value of y? So notice that this is, of course, the x value. So we can do something very similar. Start with y equals 2 times -12 plus 3. So that would be -24 plus 3. And will finally give us -21 for the y value. So finally, the last part, it says to what coordinates of the point that would lie on the y-axis. Now, on the y-axis, the x value is 0. Likewise, on the x-axis, the y value is always 0. So we can simply go y equals 2 times 0 plus 3. So that would be 0 plus 3, which of course is just 3. So the coordinates of the point, which is actually the answer to the question, would be 0, 3. And if you scroll back up to where the graph is, you can see that the point 0, 3 is on the graph. Okay, and that's it. Thank you for listening.